All right, everybody. So today I'm going to show you how to simplify radical expressions. In order to be able to simplify radical expressions, I find it useful to know your square root numbers or your perfect squares. So let's see how far you can get. The easy ones are the small ones. So 1 times 1 equals 1. That's easy. Square root of 1 is just 1. Okay. 2 times 2 is 4. And the square root of 4 is 2. Let's see what you guys can do now. So what's the next one past 4? 9, okay? Right? And what's the square root of 9? 3, right? Which one comes after 9?
16.
16. So the square root of 16 is
4.
what comes after square root of 16?
25.
Right? And that's 5. And after the square root of 25?
36.
And that's 6. Yeah. And the square root of
49.
okay, 49. Okay, we're starting to falter a little bit. What's after 49?
64. 34.
And the square root of 64 is 8. And what's the square root of
81.
That's 9. After that?
100.
Everyone knows the 100. After 100?
121.
Okay, good. After 121?
144. Hey, I said it first.
Right. After 144? This is where people tend to fall off.
Is it
156.
It's 169.
Oh, something like that.
Okay, sometimes I'll get the 13. People tend to either know up to 10 or up to 12. The 13 is, I rarely get students that get that one. Okay, do you know what comes next without?
It's 196.
Angel, stop looking at the poster.
What poster?
I do have a poster over there.
I'm not looking at the poster.
I always remember because 169 and 196 have the 6 and the 9 reversed, right? It's like, okay. After that, we have
225.
225.
Screen peeking.
Bro, I'm not screwing. You see, bro.
And after 225, we have
256.
100.
yes. And this, we're gonna stop here. We're gonna stop here just to let you know that it does get a little bit unwieldy to use these different square roots as you progress, and that maybe that's just me justifying myself. But I can get up to here automatic. Like if you ask me any of these square roots, I could tell it to you instantly. Right? Anything past this, I have to think for a second. Like square root of 289 is the next one, right? Which is 17. But after that, I only know a few. Like the square root of 400 is 20. Square root of 625 is 25. Right? So, the point that I'm making is, you can get by probably not even with all of these. If you can at least know them all up to the 100, you can probably do all right. Okay, and then you can leave the rest of it. Yeah.
Can I say something like how can we figure it out? Because like there's a pattern going on.
What is it? Are you trying to say the pattern, or are you asking?
Like a pattern is like every time of the square roots that there'll be a pattern like they'll be adding 2 to the next square root, like from 16 and 25 to 11.
That's right. So from here to there is plus 5. Yep. From here to there is plus
11.
11.
It's from 9 to 16 plus 7.
That's right.
What's all doing 9/11, bro?
This is plus 13.
Who's that 9/11?
This is plus 15.
Who's that 9/11?
That's not right.
What's up?
Yeah, we messed it up. There's definitely a pattern here. This one's plus 9. It's not plus 5. It's plus 9.
Oh, that one plus 9. Oh yeah.
That's right. Plus 9.
Plus 11.
Plus 11. Plus 13. Okay. Yes. And that's actually the pattern that we did before when we were graphing. Right? This is the parent function pattern. Right? Okay. So we could take square roots of numbers, but how can we simplify radical expressions? So earlier in this chapter, we learned that there are numbers that don't have integer square roots. They don't have rational square roots, right? Like the square root of 3. Right? It's not a decimal. It's not a rational number. It's not a integer. What's the square root of 3? It is abstractly, it's just that number. Whatever it takes to multiply itself to equal 3, that's what the square root of 3 is, right? And there's different ways to write it, but we don't have a way of writing it as a decimal or as a fraction, because it's not a decimal or fraction, it's an irrational number. So what happens when you have irrational square roots, irrational numbers and radicals that are larger? Sometimes they can be simplified. So here's an example. The square root of 12. Okay, this is where you want to start writing in your notes if you haven't already. So the square root of 12. Okay, the square root of 12 is somewhere in between the square root of 9, which is the next smallest one, that's whole, and the square root of 16, which is the next biggest one, right? So it's somewhere between the square root of 9, which is 3, and the square root of 16, which is 4. So this number is somewhere in between 3 and 4. If we're going to simplify it, when you simplify a radical expression, what you're going to do is you're going to factor that 12, okay, which is similar to dividing. You're looking for factors of the 12 that are square numbers. So, is there a square number that I can pull out of the 12? What do I mean by a square number? 1, we don't use 1, it's kind of the trivials, but starting with the number after 1, so 4, 9, 16, 25, 36, right? Those are the square numbers. So out of those numbers, 4, 9, 16, 25, 36, etc., etc., are any of those a factor of 12?
4.
4. Okay, right. So if we factor it using 4, 4 times 3 equals 12, yes? So we can rewrite this as 4 times 3. Right? And the reason we want to do that, and the reason why we're looking for square numbers, is because we can take the square root of the 4, which is 2. So the 4 comes out, in the process it gets taken the square root of, so it becomes a 2. And we can then x out the 4, right? The 4 is gone. So the final simplified version is 2 root 3. Okay, let's try one more like that. So these are kind of the easy ones. Square root of 18. Okay, is there a square number that is a factor of 18? 9, right? 9?
3. Right?
Factor.
Hey, my bad. I'm kind of slow.
So 3 is a factor of 18, but 3 is not a square. You can't take the square root of 3.
Yeah.
It's not a square. Okay.
9 is a factor of 18, and you can take the square root of it. That's what we wanted. So it's 9 times 2, right? 9 times 2 is 18. We can take the square root of the 9, which turns into a 3, and we can get rid of that 9. That gives us our final answer, 3 root 2. And that's how we say it. We say 3 root 2, or 3 root 3 for the problem came before. Okay. Now, sometimes you'll get numbers that are a little larger, and how many square roots you know, and how large of a square root you choose to factor it into, can play a role in how quick you can simplify it. So let me give you an example of that. Let's say we're going to take the square root of 128. Okay, so 128 can be factored using square numbers, or using at least one square number. What square numbers can be factors of 128, or are factors of 128? Let's go in order. 4. Can it be divided by 4? 128 divided by 4?
I think so.
It is, right? 4 times 32. Okay, so option 1, right? We could rewrite this as 4 times 32. If we did that, we could take the square root of the 4, which gives you a 2. And then we'd get 2 root 32. The problem is that 32 can be further simplified. There's another square number in 32.
6. Is it 16 or?
You could choose 16, or you could also say there's another 4 in there, right? I heard you say 16, so let's go with that. So you can write the 32 as 16 times 2, right? And the 16, the square root of 16 is 4. So on the outside of the radical, you have 4 times 2, which is 8. And on the inside of the radical, the only thing left over is just this 2. So you have 8 root 2. Okay? And the 2 can't be further simplified because there's no factors that are squares that can factor the 2. So that's one option. Okay, that's the answer. But look what happens if we pick the highest square number. We can actually shorten this process. So instead of choosing 4 at the start, let's go the other way. Let's start big and get smaller. What's the biggest square root number that you're comfortable with? That's smaller than 128. So probably like 121, right? This is square root of 121 is 11. Can this be factored with 121? 121 times an integer equals 128. No. Okay, so let's go the next one down. 100. No, right? 81. No. 64. Yes. So see, by doing it that way, we're making sure we're choosing the highest square number. So this one, option 2, is we could have broken this down into 64 times 2. And the square root of 64 is 8. And that gives us our answer, 8 root 2. Same answer, different process, because in this one, we purposely went out of our way to choose the highest square number to factor. In this one, because we chose a lower square number at the start, we had to continue to simplify. It took more steps. Both ways are valid. There's not necessarily one way that's better than the other, unless you're aiming at something specific like speed or I guess the ability to check it mentally can be easier if you choose smaller numbers. But since they both give you the correct simplified response, then they're both valid, okay? And what does this mean? It means even if you don't know, if you're not confident with all of your square numbers, you know, up to 256 or 289 or beyond, you can still usually make do with a smaller set of square numbers, right? Like if you only know the ones up to 100, 4, 9, 16, 25, 36, 49, 64, 81, 100. And even if those are the only ones you know, it should be fine, especially as some of these get bigger. You just need to continue to simplify using the smaller ones. Okay. All right, so that is simplifying square root radical, or simplifying radicals with numbers. What about with variables? So let's take a look at variables. Okay, let's start with x times x. How do you write x times x? What's x times x?
1 times 1.
X squared. Okay, so what's the square root of x squared?
X.
That's x root x. It's just x. Right, the square root is just saying what times what equals x. Okay. What's x squared times x squared?
X4.
X to the 4th. Now, in my previous 2 classes, they both struggled with x to the 4th. So I'm gonna still give this explanation that I gave to my previous classes because I think students can find value. So the reason why it's x to the 4th, which is correct, is because x squared is x times x. So is this one, x times x. So if I multiply them together, I have x times x times x times x. How many x's am I multiplying together? 4 of them. So that's why it's x to the 4. Okay? So what's the square root of x to the 4th?
X to the
X squared. Right, because x squared times x squared equals x to the 4th. Okay? What's x to the 3rd power times x to the 3rd power?
X to the 9th.
It is x to the 6th power. Because, so same idea, right? X to the 3rd power is x times x times x. And that happens twice. And so what happens when you group them together? You're multiplying 6 x's together. It's x to the 6th power. So what is the square root of x to the 6th power?
X to the 3rd.
X to the 3rd power. Okay? What's x to the 4th power times x to the 4th power?
X,
X to the 8th.
X to the 8th power, and what's the square root of x to the 8th power?
X to the 4th.
X to the 4th power. Okay, you're seeing the pattern now, hopefully. What's the square root of x to the 10th power?
X to the 5.
Fifth power. What about the square root of x to the 12th power?
X to the 6.
Yes. What's the square root of x to the 20th power?
X to the 10.
Yes. What about the square root of x to the 50th power?
X to the 25th power.
Okay, so what's the rule? If you're taking the square root of a variable that has an exponent, what's the rule?
It's always going to be divided by half.
Divided by half. Cut in half, right? Divided by 2. So, all we're doing is we're taking the exponent and dividing it by 2. Okay? And that works out because all of these exponents are what kind of numbers? Let's take a second. Look at these exponents, right? So 2, 4, 6. What are these numbers? What do they all have in common? They're all positive, that's
they're
true.
even.
They're all even, right? So we can take square roots of variables with even exponents, and it comes out to a rational number, or potentially, maybe not rational, but it comes out to an expression that doesn't have a radical, right? So what do you do when it's odd? What about x to the 13th power? What's the square root of that? Here's what you do. Okay, when you're simplifying x to the 13th power, notice 13 is odd, so you can't yet do the cut in half thing. Later we'll work with fraction exponents, but for now we're not going to do that. What you're going to do is you're going to factor x to the 13, you're going to separate it. It's going to be x to the 12 times x to the 1. Like this. And we take the square root of x to the 12. The square root of x to the 12 is x to the 6. That goes away. And so we are left with x to the 6 times root x. See? Okay. One more like this, and then I want to show you one more problem that kind of puts everything together, and then we'll be done. So what about the square root of x to the 25? You're going to separate it out. X to the 24th times x. The square root of x to the 24
Is x to the 12.
is x to the 12. This goes out. And so you have x to the 12 root x. And that's simplified from x to the 12. Okay, final thing, let's put it together. So numbers and variables together. Let's say you have a problem, an expression, something like, let me think of a good one. Let's say you have 72 times x to the 5th power times y to the 8th power times z to the 11th power. Something like this. What you're gonna do is you're gonna simplify each
Every one.
each number and variable kind of separately. Right? So the 72, let's start with the 72. Let's think of square numbers that we can factor into 72. So 4 can work, 9 can work, because 9 times 8 is 72. If 4 can work and 9 can work, that means 4 times 9 should also work, 36. 36 times 2 is 72. You see what I just did there? The 4 could work and the 9 could work. So instead of pulling out the 4 and the 9, put them together. 4 times 9, 36, right? So I can pull out a 36. Okay. So 72 is 36 times 2. The 36 is going to come out, become a 6. 2 stays in. So I'm going to go ahead and start writing our answer down here like this. 6 is out, 2 stays in. And that's the number part. Now let's do the x part. X to the 5th power. It's an odd exponent. So what do we do?
X, 4, and X1.
Oh, yeah,
Right,
four,
x to the 4 times x to the 1. Yep. And
X2.
that becomes x to the 2nd power,
Second power.
and that stays as x. Now we do the y. It's y to the 8th power. It's even. So what should we do?
Just simplify, like, divided by 2.
Yeah, we can just pull the whole thing out. We don't have to separate it or anything. So this one is just going to be y to the 4th power. Nothing gets left behind in the radical. And then the z, we can split up the z
Z to the 10th power.
times z to the 1. The z to the 10 can come out of the radical. It becomes z to the 5th power. And this z to the 1 stays inside. And that is considered simplified.
That's right.
That's considered simplified. Okay.